Far away in the vast stretch of the night sky lies a star that has captivated the curiosity of astronomers and skywatchers for centuries. A colossal, fiery red giant known as Betelgeuse. Located in the constellation Orion, this massive star is one of the most luminous and largest visible to the naked eye. It shines like a bright ruby on the hunter's shoulder, a celestial jewel that carries both beauty and mystery in equal measure. Yet Betelgeuse is not just a glowing ornament in the sky. It is a ticking cosmic time bomb, a star that is nearing the end of its life, and when it finally explodes in a dramatic supernova, the event could light up the night sky with a brilliance unseen in recorded history. Betelgeuse sits roughly 642 light-years away from Earth, close in astronomical terms, and it is enormous. To grasp its size, consider this. If Betelgeuse were placed at the center of our solar system, its outer edges would extend beyond the orbit of Jupiter. That's a radius about 1,000 times that of our Sun. In terms of volume, it could swallow billions of suns. And yet, despite its massive size, Betelgeuse is relatively light for its class, only about 10 to 20 times the mass of the Sun. This discrepancy is due to its swollen and diffuse outer layers, a trait characteristic of stars in the red supergiant phase. This is a critical stage in a star's life, the final act before collapse. Having exhausted its hydrogen fuel, Betelgeuse is now burning through heavier elements in a desperate attempt to maintain equilibrium against gravitational collapse. But that battle can't last forever. Eventually, Betelgeuse will lose the ability to support itself. Its core will collapse, and the star will explode in a supernova of tremendous magnitude. It's not a question of if but when. In late 2019, astronomers noticed something strange. Betelgeuse, normally one of the brightest stars in the night sky, began to dim significantly. Over several weeks, it lost more than two-thirds of its brightness, prompting headlines around the world. Was Betelgeuse about to go supernova? Was this the final flicker before the celestial giant met its end? The astronomical community watched with breathless anticipation, hoping to witness a cosmic spectacle of unprecedented scale. But the dimming turned out to be something else. Upon further analysis, researchers concluded that a gigantic cloud of dust, ejected by the star itself, had obscured its light from our vantage point. Essentially, Betelgeuse had burped out a chunk of itself, an enormous mass of gas that condensed into dust and blocked its own glow. This event, while not a sign of imminent collapse, still indicated that something unusual was happening. Stars like Betelgeuse often become increasingly unstable as they near their final moments, shedding mass in dramatic and unpredictable ways. Since then, Betelgeuse has returned to its usual brightness, but the questions haven't gone away. In fact, they've only deepened. Astronomers now wonder whether that dimming episode was a preview of what's to come, a symptom of internal chaos that could eventually lead to its demise. But understanding such a complex and distant object is no easy task. Betelgeuse's surface is not smooth or uniform. It boils and churns with colossal convection cells, each larger than our own Sun. These currents push plasma to the surface, which cools and falls back down, creating a seething, restless star. Modern telescopes, including the Hubble Space Telescope and other ground-based observatories equipped with adaptive optics, have even managed to image Betelgeuse's surface directly, a rare feat in astronomy. These images reveal a star that appears almost lopsided, irregular in shape, with bright and dark patches that shift over time. It's as though Betelgeuse is constantly trying to hold itself together while forces within threaten to tear it apart. When Betelgeuse finally does explode, the resulting supernova will be spectacular. Some models suggest it could shine as brightly as the full moon in Earth's night sky, possibly even be visible during the day. It would linger for weeks or months, a glowing beacon of cosmic death and rebirth. And while this might sound terrifying, it's important to remember that Betelgeuse is far enough away that the explosion won't harm Earth. The radiation will spread out as it travels, and by the time it reaches us, it will be more of a light show than a threat. Still, such an event would be the closest supernova visible from Earth since Kepler's supernova in 1604 and would offer a once-in-a-lifetime opportunity for astronomers to observe the death of a massive star in real time. Instruments all over the world, and in orbit, would turn toward Orion, capturing every wavelength, every pulse, every fragment of data. From X-rays to radio waves, the information gleaned from a Betelgeuse supernova could reshape our understanding of stellar evolution, the mechanics of explosions, and the distribution of elements in the galaxy. Indeed, when massive stars explode, they scatter heavy elements, like iron, calcium, and gold, into space. These are the building blocks of planets, of life, of us. In a very real sense, we are made of stardust, the remnants of ancient supernovae that long ago seeded our corner of the galaxy. When Betelgeuse dies, it will contribute its own ingredients to this cosmic recipe, enriching the interstellar medium with the materials needed for future worlds. One reason Betelgeuse fascinates us so much is because it's not only a scientific marvel but also a cultural and historical icon. For millennia, people have looked up at Orion and noticed the bright red star marking the hunter's shoulder. It has been mentioned in ancient texts, tracked by sailors and astronomers, and woven into the myths of countless civilizations. In some cultures, it was considered an omen, its fiery glow a warning from the heavens. Now, in our age of telescopes and space probes, Betelgeuse has transformed from myth to measurement, from legend to laboratory. The question that lingers, however, is when? When will Betelgeuse explode? The honest answer is, we don't know. It could be tomorrow, or it could be in 100,000 years. In cosmic terms, that's the blink of an eye, but for us, it feels like a lifetime. What we do know is that it's very close to the end of its life. The fusion in its core is progressing rapidly, and eventually, the iron core it builds will become unstable and collapse under its own gravity, triggering the final explosion. Astronomers are working hard to pinpoint signs that might indicate the exact moment of collapse. They monitor neutrino emissions, gravitational waves, and subtle shifts in brightness and surface temperature. They model the internal physics of red supergiants using massive computer simulations. But stars are complex, and the timing of a supernova remains one of the great unsolved challenges in astrophysics. Interestingly, Betelgeuse could even have already exploded, and we just don't know it yet. Remember, it's over 600 light-years away, meaning that any light or signal we see from Betelgeuse is already centuries old. If the star went supernova in the 1400s, the light from that event wouldn't reach us until now. It's a strange and mind-bending thought, that at this very moment, the explosion might be racing toward us at the speed of light, soon to erupt in our night sky. Until that moment arrives, we continue to watch and wait. Betelgeuse is like a cosmic time capsule, offering us a preview of our own sun's distant fate. Although our sun will never go supernova, it too will swell into a red giant, shedding its outer layers before becoming a white dwarf. But for now, Betelgeuse is the more dramatic player on the stage, a star nearing its final bow with all the grandeur and suspense of a Shakespearean tragedy. And perhaps that is what makes Betelgeuse so compelling. It is not just a star, it is a story. A story of birth in a stellar nursery, of growth into a magnificent supergiant, of instability and violent convulsions, and of an inevitable end that promises both destruction and creation. Its light has traveled across time and space to reach us, a message from a giant on the brink of oblivion. And we, tiny observers on a pale blue dot, look up in awe, waiting for the final act. So the next time you gaze up at Orion on a crisp night, find that red star twinkling on the hunter's shoulder and remember, you're looking at a dying giant, a brilliant flame soon to be extinguished. And when it finally does go dark, the sky will never be the same. But in its death, Betelgeuse will give birth to something new, a nebula, perhaps, or a neutron star, or even a black hole. Its story will continue, not just in the cosmos, but in our hearts and imaginations, forever etched into the grand chronicle of the universe.